we can actually try to test out the shell itself on the target system. If all works well, that means we can continue to add different types of functions to our shell, and we can add some of the things such as running at system boot, for example, putting the file in the registry key, self-copying the file, basically screenshotting targets, running keyloggers, and so on and so on. But before we do all of that, we actually have to make sure that our shell works properly. So let me enlarge this terminal. So view, zoom in, and let's go to the Python where my reverse directory is, where we have our reverse shell. So if I nano it, we can see everything that we did for now. We have these two functions for receiving and sending. We have the shell function, which for now on only basically quits the function or the program itself once we specify Q as a message or as a command, or in any other case it will try to execute the command on the target system. If the command can't be executed, it will send this string, can't execute that command. So right now what we want to do is actually run this program on our Windows machine. But we all know, in order for a program to be an executable and to be able to run it to the Windows machine, we have to make the .exe file with this reverse shell. For that, we will use the wine and the PyInstaller that we installed in the system hacking section. If you didn't go over that section, make sure to check out the video Wine installation, since there I showed how we can install the Wine program, which allows us to use Windows programs on Linux systems. There we installed the Python 27 version, and there we also installed the PyInstaller, which we will use to compile this program into .exe version. But before we do all of that, we need to change a few things right here. So you might notice that basically we cannot connect to the 127.0.0.1. Once we run this on a target system, we actually have to specify the IP address of our Kali Linux machine. So let us close this and check out our IP address. So it is .1.9. We take this IP address right here, we can copy it, and right now we need to go to our reverse shell, find the connect function, so here it is, sock.connect, and instead of the localhost IP address we specify our own IP address. This is because the reverse shell will run on a target system, so we need to specify to which IP address the reverse shell should connect to. We specify the IP address of Kali Linux machine, so our target will connect to our Kali Linux machine. Now, keep in mind that this IP address will only work on localhost, so if you were to run this over the internet, this attack, you would need to specify either to port forward this IP address on your router, or to use, for example, ngrok in order to run the attack over the internet. Here you would specify the IP address of ngrok site, and here you would specify the IP address, or pardon me, the port that ngrok has given to you. Now we will do all of that even later on, but for now on let's just do the attack over localhost. I will leave the port to be 54321. So also another thing to make sure is that the port isn't in use on the system, on your Kali Linux system, so keep that in mind as well. And this should be good to go. Now we need to change these things also in our server, so nanoserver.py. In our server we can see we have similar functions, so for sending and receiving data, the shell function which sends the commands to the target system, and the server function which actually performs the connection, or basically performs the listening part of our server. Here we can see that we binded the IP address of localhost in 54321. We need to change the localhost to the IP address of our Kali Linux machine, so just copy paste it right here. Now, if you don't have any programming knowledge, you might be asking why are we pasting the same IP address in both of our programs. Well, basically the server program is the program that we will run as a listener on our Kali Linux machine. So that is the program that we don't send to anyone, we run it ourselves. And the reverse shell program that we saw previously is the program that we send to the target and that the target executes, and basically that program will perform a connection back to our server. So we need to specify on our server the IP address and local port on which to listen to, which is our IP address and our local port that we choose. And on target we need to specify the connect function to the IP address of our Kali Linux machine, which is the same as here, and to the same local that we chose. So that should be it. We need to save this as well. And all we have to do right now is make sure that we have the root.wine folder right here. If you click here ls, you should make sure to have drive C as well. In the drive C, if we go there, you should go to the Python 27 right here, and in Python 27 you will see a directory called scripts. In that directory, there is where we installed our PyInstaller.exe. So change our directory to scripts ls, and here we should be able to find the PyInstaller, which is right here. So if you do not have this PyInstaller right here, as I said previously, make sure to check out the wine installation video that I did in system hacking section. But right now, since we have it, we can compile our program with no problem. So let's go back to our reverse shell directory. So root, Python files, reverse. And all we have to do is compile our reverse shell.py. We do not need to compile the server.py, since the server is something that we will run on Kali Linux machine. And it is already executable for Linux systems. We only need to make an exe version of this shell right here in order to run it on Windows systems. So how we do that? We need to specify the wine right here, since as we said before, the wine is a program that we use to run the Windows programs on Linux. So we need to specify wine, since we will be running the Python for Windows that we downloaded in our wine folder. And we need to specify the path to the PyInstaller, which we will use to compile the program. So the path is root.wine, drive C, Python 27, scripts, and then PyInstaller.exe. You need to specify this path. It should be the same for you. If it is not and you actually installed the program into some other directory, make sure to find that directory, have all of this in there. So have PyInstaller, Python 27 under the scripts, and make sure to specify that directory. Now after that, we want to specify the name of our file that we want to compile, which in our case is reverseshell.py. And basically this could be it, but we want to specify a few other options that we will use in order to make our program more appropriate for this task. So for example, if you were to run this, it would give you a folder full of files and libraries that need to be used in order to run the .exe version of our reverse shell. But we only want to make the entire program to be one file, so we need to compile the reverse shell into a one file and not a bunch of files. So we will specify the option right here. So specify -- and then one file, just type here with words, so one file. And also when we run the program, we want to not be able to see the console. Now the console is basically the command prompt, so sometimes when you open programs, the command prompt will pop up in waiting for some task to finish. We do not want to prompt the user with this window right here, since that would be suspicious. What we want to do is basically user to double click the file and to think that nothing happens. So nothing will be opened once the user runs our reverse shell. So that's what we want to achieve. In order to achieve that, we need to specify -- no console, so that console doesn't pop up, and this should be good. And right now, if I click here enter, this should start compiling our reverse shell.py into the reverse shell.exe. So this will take a few seconds. All should be done well, and you might notice that at the end of this compile, our program will be significantly bigger. That is because this adds a bunch of other programs as well to it, a bunch of other libraries, and all the things it needs in order to make this an executable. And right now we see that our compiling has finished. So it says right here, building exe completed successfully. So let us just ls once again, and you will see we get a bunch of different things added to our directory. We get a directory called build, a directory called dist, and also something called reverse_shell.spec. Now where we want to go is we want to go to the dist directory, so change our directory to dist. Let us clear our screen a little bit and type here ls. And in our dist directory we have our compiled program. This is what we have to deliver to our target. So what you want to do right now is deliver this however you want. I will use my USB drive, so I will just plug it in right here, go to devices, USB, and choose your USB drive right here. In my case, this is the Kingston Data Traveler, and I will plug it in. Then it should pop up right here that the USB drive has been plugged in. That's good. So we click the USB drive, and I will copy the file with my terminal. So we have the USB drive called Kali Live. I will close it since I don't need that window open, and I will just copy, or I can actually move. Don't need to copy since I don't need the reverse shell exe on my system. Move it to media, root, and then Kali Live. Now, if you do not know how to copy this or you do not know the name of your USB drive, most likely, if you just after the media/root type tab, it will prompt you with the available options for the ending of that command. Now I just tapped, and since only I have one USB drive plugged in, it basically found it by itself and it's named it Kali Live. So if I move it right here, I move the program there, and now my reverse shell.exe should be on my USB drive. So now what we can do, if I just type here ls, nothing in this directory, now you can remove all of these things that the compiler has made. So we can remove the build -r, we can remove the dist -r. Now remember to use -r for the directories, and the reverse shell we can use without the -r. So just make sure to delete the right one, don't delete the reverse shell.py, delete the reverse shell.spec. And now we should be left with both of these programs that we had even before the compiling of our reverse shell.py. So right now what we want to do is unplug our USB drive and run the file on our Windows machine. So continue without scanning, and we have my reverse shell right here. I will paste it on my desktop. We can see it is .exe. The size of that file is a little bit large, so if I go right here, you can see that the size of the file is 3.45 megabytes, which is kind of large. Not too much, but it's still something. So that could be the only problem with this thing, since it adds the size to the file once the PyInstaller compiles it to the exe. That's why the file becomes so big, but that's something we can't change, so let's not think about that. Let's actually now run the server. So make sure before you actually run before the target runs this, make sure to set up a listener by running our server.py. As we can see, listening for incoming connections, and right now if you send this to the target and target runs it, you can see that nothing really happens right here. There is no window popping up, there is nothing. It basically looks like the program didn't run at all. But if we go to our Kali Linux machine, you can see the target connected. Shell from this IP address, which is the IP address of my Windows 10 machine, which I can show you right now. If I open my command prompt and just type here ipconfig, we can see that the IP address of my Windows 10 machine really is 192.168.1.3. This port right here is the port from where the connection is coming from on the Windows 10 machine. The local port that we listen on was 54321, and this is the port from Windows 10 machine that is sending the packets to us. So right now you will notice if I, for example, type here dir, you can see that I actually get the list of all the files on my Windows 10 desktop. As we can see, they really are there. So here is Handbrake, Kali Linux, Master Ethical Hacking.jpg, Metasploitable, new folder, Record, OWASP, and all of these things that really are on my desktop currently. If you were to, for example, run arp-a, you would get all the ARP tables of our Windows 10 machine, which currently only has the router and my Kali Linux machine in there. If you were to, for example, shut down the PC, it would shut down the Windows 10 PC, including our Kali Linux machine, so we will not do that since there is no point to do that. So we can see that our shell works perfectly. We can, the one thing that we can do, so for example, pwd doesn't work in the Windows 10 environment, so let's just type who am I. We can get the name of the account, so we can see which account are we on. And basically, the one thing that doesn't work, so if you notice, if I just type here dir once again, I'm currently in this directory, but for example, let's say I wanted to go to the one directory back. So I would do that with cd ... and you would see if I type dir once again that I am still in the desktop directory. Now that is something that we have to fix, since we are only for now on able to execute commands in the current directory. We are not able to change the directory to some other folder, or change the directory back one folder or two folders, or basically go to anywhere we want. So we want to make sure to fix that, or not to fix that. There is a command, we need to import the OS library in order to be able to execute, but we will do that in the next videos. For now on, it is good that we actually know that our shell is good and that is running on both Windows and Linux, even after compilation. So that would be about it for this video. Now let's see, before we actually end this video, let's see how the target can close this program. So if they go right here and try to delete this, they will get prompted the action can't be completed because the file is open. So they can delete this file as long as we are on PC, or basically as long as we are performing the connection. As soon as we close the connection, they will be able to delete this file, and they will delete this file. Now, anyone who knows a little bit about computers knows that they can just go to the task manager, find the reverse shell.exe and end the task right there, which basically would terminate our connection right here. So what we want to do is basically copy the file itself and make it also persistent, and make a registry key for the file that we copied, so it can run every time a target system boots up. So we will be looking at that as well, because right now if the target knew how to open the task manager and found the reverse shell, they would just go to the end task and they would end the reverse shell itself. So that is another thing we have to take a look at, so we can actually have a usable shell and not something that the target can close anytime they want. So if I just type here Q, we should be able to see that the target and the target communication or connection and the server connection has been terminated. So right now, if we just delete this, we can delete the file since we closed the connection. So we will see how we can fix all of that, and that will be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye!